so in part 2 of the lesson, all right, on Friday we talked about fractions. We reviewed some of the one-step equations. We're going to continue that today and start out by reviewing decimals. I know we're kind of skipping a section, but I want to review the decimals before we start solving equations with decimals. All right, so when I'm adding decimal values, what's my number one rule? Y'all just tell me, what's my number one rule?
Keep the decimals like put together.
Yes, line up those decimals. Okay, now it doesn't matter which number goes on top. If you put 125.4 on top, that's fine. Okay, as long as those decimals are lined up, you should have got the right answer. All right, 149.04. Anybody get that? Okay, so good news. We're good on the adding decimals. Now, subtracting decimals. This is important because they're going to throw in these negative numbers. Okay, when you're subtracting decimal values, you have to, doesn't matter, okay, which one is in which place. All right, well, it does matter, but not necessarily for actually doing the subtraction. When it's a subtraction sign, 7.46 is positive or negative? Tell me. It's positive. 9.64 is negative, so that's different signs, okay? What's my rule when numbers are different signs? To subtract them. And you have to subtract their absolute values. Okay, so we're not worried about the sign. When you subtract decimals, the bigger one has to go on top. Otherwise, you're going to run out of digits. Okay, so you just told me they're different signs. So that means you have to subtract their absolute values. Are you with me? Okay, so you're going to look at these decimal problems. All right, you're going to see this a couple times this week because this is one of the concepts that kind of get missed sometimes. If you see subtracting decimals and one is positive, one's negative, put the bigger one on top and subtract them. Okay, so go ahead and subtract these decimals. Go ahead and subtract them now. Do y'all understand why we switched the order? Because the bigger one had to go on top. Okay, we'll come back to the sign here in just a minute. Go ahead and subtract them. What'd you get? 2.18. Okay, so now the question is your answer positive or negative? Negative. Okay, go back to the original problem. Okay, which number had the greater absolute value? 9.64, and it's negative. So your answer is negative. Just pop in a negative down there and you're done. Okay, so you see what happened there? Now, guys, if that had been an addition sign there, you just add them together just like the first one. The order doesn't matter. But if you're subtracting them, got to put the bigger one on top and then go back to the original to figure out the sign of your answer. All right, go ahead and multiply the next one if you haven't already. Go ahead and multiply. So what's my rule for multiplying decimals? Line up the digits. Line up the digits, okay? So the digits need to be lined up, not the decimal, okay? So you see 5.41 had more digits. The number that has more digits has to go on top when you're multiplying, okay? And then just line up the digits to the right and then multiply, okay? How do you know, I accidentally put it up, how do you know where your decimal goes in the answer, Josh?
If it has, like, you kind of add, like, how many times the dot.
Yep. Yep, up here, right? Go back up to the top, right? And what do you count up top?
3.
You count 2 here, yep, very good. And you count 1 here, so that's 3 decimal places in our answer. And we're done. Anybody get 12.984? Did I get that right? Okay, 12.984. All right, now let's divide. Let's divide decimals. Which number would go on the inside of the long division?
6.4.
The first one, okay? The 6.4 goes on the inside, and the 0.8 goes on the outside. But I cannot have a decimal in my divisor. So what can I do?
Move it to the right.
Move it to the right. However many places. Now, on the inside, I can have a decimal. That one I'm not concerned about. But however many places I have to move it on the divisor, The same thing has to happen on the dividend, the one on the inside. So what's going to happen to my decimals? Yeah, they're gone. They're canceled out. Okay? Oops, did not mean to do that part. Okay, so they're gone. Now, what's 64 divided by 8? 8. Okay, and that's my answer. All right, so when I'm solving these equations, and it won't always be this way, but because chapter 1 is so heavy on review of decimals, review of fractions, you are going to need to do these by hand when you're solving the equations, okay? And that's what we're getting to in the next slide. All right, on the next slide, we're solving an equation, just like we did on Friday, except now I have to add and subtract the decimals, all right, and the fractions. So on the first one, I have to ask myself the same question that I was asking in the earlier examples. What operation is connected to my variable? Addition. So what would I need to do to get y by itself? Subtract. 3.4, okay? So I minus 3.4 from both sides. Now, this is the part that if I had my calculator, it would be super easy. What's up? Oh, I was switching over. I subtract 3.4 from both sides. If I had my calculator, it's just a couple punches of a button and I'm done. But I don't because I need to review these decimals. So what you have here, okay, this is why we review decimals first. Do I have same sign or different here? Different. So my rule says I need to subtract them. But what number is going to go on top? So you're going to, over on the side, 3.4 goes on top when I need to subtract. Okay? The larger absolute value goes on top. So you just told me these were different signs here. 0.5 is positive, 3.4 is negative. So I need to subtract their absolute values. That's what I'm doing over here. Go ahead and subtract them. Okay? You're going to need to do this by hand if you can't do it in your head because you won't have a calculator. All right? What's 3.4 minus 0.5? Okay, it's 2.9. And I heard someone say negative. Why negative? Yeah, 3.4 was negative and that was the bigger one. So my answer is negative 2.9. Okay? Now, checking will be optional. Checking will be optional. But you do it the same way. It's going to be optional because time will be a factor on these quizzes and tests. But I want to show you at least one. You can plug it back in the same way that you plug in every other equation to check. It's just going to be harder to check it in mental math. All right? So again, this is different signs, so you can subtract and take. 3.4 is now bigger, so I know it's going to be positive, and when I subtract them, I still get the 0.5. Okay? So I just wanted to show you that because you can check these the same way that you check them with whole numbers. All right? How are we doing? Doing okay? You kind of see how they're pulling in all these concepts that you already know how to do from your other years in math, but we're just really pulling them all in together. Okay, so now we have over here, t minus 1/4 equals negative 3/4. So, first question again, what operation is connected to my variable? Subtraction. So what do I need to do to get t by itself? Add what? 1/4. Add 1/4. Okay? And I need to add 1/4. Whatever I do to one side, I do the same thing to the other. Okay? So here's where I kind of hold my breath a little bit. Are these ready to add together?
Yeah.
Are they ready?
No. Yes. Wait, oh yeah.
Why are you saying yes?
Because I have a common denominator.
Because they have an LCD. So can I warn you, you have a homework problem tonight where you have fractions and you're going to need to find the LCD. Okay? Hopefully we'll be able to work on that together in a few minutes. Okay, so because there is an LCD, what can I do to simplify?
Yeah.
Add what?
3 plus 1.
Not 3, but Negative 3. Do I add my denominators together? No. No. Okay. So negative 3 plus 1 is negative 2 over 4. You just bring your denominator down and then make sure you reduce. Negative 1/2. And again, you could check. You could also check. All right, but checking will be optional. All right. All right, next slide. We have another fraction here, but it's connected to the variable in a different way. How is it connected to the variable? Multiplication. This is a fraction being multiplied by a variable. Okay, well, what's the opposite of multiplication? Division. All right, now I want to show you something. You don't have to write this down. But what you're telling me is I need to divide both sides by negative 3/4, correct? Okay, so I'm going to show you how that looks side by side. You're telling me it's going to be negative 3/4 because it's multiplication with the n needs to be divided by negative 3/4, right? All right, what do you remember about your rule of dividing fractions? Keep, flip, change, okay? So instead of writing it like this, we're not going to write it this way, okay? So hopefully you haven't written anything. If you have, erase it, okay? Because we're not going to write it dividing a fraction. It gets confusing on what to do on the other side, okay? But I need you to see this to understand why we're writing it like this. Negative 3/4 times negative 4/3. You see what we did there? We did the KFC, the keep, flip, change. We flipped the second one and we changed the operation. All right, so I'm going to erase all this. This is what you're going to write, but I needed to show you why. Okay? So, because you need to divide by a fraction, we know that dividing fractions actually means multiplying by the reciprocal. And what happens is those cancel to 1. That's what I want. So anytime you see, okay, you understand the why, because dividing a fraction, we keep, flip, change. Okay? Anytime you see a fraction multiplied by the variable, you will flip it and multiply. Okay? To get it to cancel. We clear? So now ends by itself. Yay. Mission accomplished. All right? However, n doesn't equal negative 2. That's not my answer. What did I forget to do?
Oh, do it to the other side.
What did yeah, exactly. I multiplied by negative 4/3 to get it to cancel, so guess what? Multiply the other side by negative 4/3. Okay? Multiply. All right? So go ahead and multiply those. Reduce it if you can, but don't make it a mixed number. Is my answer going to be positive or negative? You are right. Why? Why is my answer positive? Very good. What's negative 2 times negative 4?
Negative 8.
Yeah, you're right. It's positive 8 because that's 2 negatives, and then what's 1 times 3? 3. Okay, so n equals 8/3. And you can leave it like that. And honestly, guys, don't change it to a mixed number. That's just one more step, and it's not needed. Okay? What do you guys notice about the second one that's, like, really weird? Yeah, there's a pi. Like, what in the world? Pi? Okay, we're still solving for x. All right? So what operation is connected to x?
Pi times x.
Multiplication. So what do I need to do? No, don't change it to a number. Just divide by
3.14.
no pi. Okay? And we know when we divide by pi, this cancels. That's what we're trying to do. If this is multiplication and I divide, then it's going to cancel. It's going to cancel down to just a 1. So whatever I do to one side, I do to the other side. Well, if it canceled on the left side, guess what happens over here? It's going to cancel again. Okay? And x equals what?
3.
3. All right, so they like to throw this in here. Why? Because it's still reinforcing and it's showing us when I divide, it can cancel down to 1, and it does it on both sides here. Okay? All right, so just trying to reinforce those opposite operations. Questions? Okay. I think this might be the last two that we're working. It looks like, yeah, the last two equations, and then we'll do a couple other things. All right, so I need to solve for W on this one. All right, well, what operation is connecting 0.09 and W? Multiplication, so what do I need to do? Divide both sides by what? By 0.09. Again, with no calculators, they want us reviewing dividing decimals. Okay, so this right here, I need to do what? Yeah, do the division. Which number goes on the inside?
1.8.
Yeah, 1.8 goes on the inside. Which number goes on the outside? 0.09. Okay, all right. I want you guys to go ahead and do the long division here. Okay, to divide these, and then whatever you get, that's what's going to be the answer, the W equals. I'm going to walk around and check on you guys. So how many times do we have to move our decimal? 2. We had to move it 2. So how many times do we have to move it on the inside? 2. So what does that mean you need?
Add a 0.
A 0. Okay. So now I'm going to clean this up. I'm going to get rid of that decimal there. I need to make that a little smaller. Okay. And move this arrow. Clean that up. Okay. So now I'm ready to divide. 9 goes into 18 how many times? 2. But then when I put 18 here and I bring it down, it's just 0. Well, my decimal place moved here. So what do I need after the 2? Another 0. 9 goes into 180 20 times. W equals 20. Okay, you guys are good on that.
Do we have to put it W equals?
Yes. Yes. Okay, so that's a great question. Don't forget that you're solving an equation here. Say, well, I'm so proud of myself. I did the long division. I got it right. Well, that's good, but that's not what you were doing. You were solving an equation. So you do have to write W equals. You would lose a point there. All right, let's do the next one. Negative 2/3, negative 2z over 3 equals 6. Okay, so the one thing that's different here is z is actually in the numerator. Okay, but don't forget, it's still being multiplied. There's not a plus sign here. All right, so I still need to get rid of this fraction. You guys remember what I said to do? Okay, so I'm not going to give you any other hints. I need you to get this fraction to cancel out, so we just have a z. Okay, you're going to do something over here. All right, go ahead and try that. Micah, what did you do?
Changed it and then
Yes. Yeah, what did you multiply by? Yes, very good. Negative 3 over 2. He's like, I know what I did, but you're asking me to explain it. And that's a little different, isn't it? It's a little tricky. Great job. Anybody else multiply by negative 3 over 2? You got to flip it. Keep the negative. Okay, so it completely cancels out. Great. Z equals 6. Right?
Yeah.
What did I forget to do?
Do it to the other side.
Do it to the other side. Multiply 6 over 1 times, don't forget your negative, 3 over 2. Okay? 2 options here to solve. We're almost done. Nick?
6 times 3 is 18.
Okay.
And then 1 times 2, 2. So
Okay.
it's negative 18
Yep.
over 2.
Yep. And then what does that reduce to?
9 over 1.
Or don't forget your negative.
Negative 9.
Yep. Negative 9 over 1 or just negative 9. Could he have done something up here to avoid having to reduce at the end? Either way, it's fine, Kelsey. Yeah, so he could have cross-reduced up here, the 6 and the 2. And guys, here's why this is helpful. It keeps your numbers small because you don't have calculators, so you don't have to deal with huge numbers. Either way, on this one, you're going to be fine. If you don't cross-reduce, no big deal at all. All right, because we all got to the same answer. All right, any questions? Any questions? We doing okay on these? A little more complicated, but we're okay. We're just kind of bringing some stuff together. All right, this one is, they kind of get into these like puzzle type questions, and they're pulling together a lot of information here. What value of k would make this true? Now, you have to keep in mind order of operations. Otherwise, you're going to get this kind of question wrong. What do I need to do first?
4 divided by
PEMDAS.
0.2.
Yes, PEMDAS. Very good. I must divide before I add. Divide. Go ahead and do this, guys. 4 divided by 0.2. We need to know what that simplifies down to. Okay? We need to know what that simplifies down to. Go ahead and divide that. Just real quick, you're going to have to do some long division. What's 4 divided by 0.2? Someone tell me. What is it?
20.
What'd you get? It should be 20. Okay? So, k plus 20, I simplified that, equals 5. All right? Well, what operation is connected to k?
Addition.
Addition. So you might even be able to do that mental math, and that's fine too. But I would subtract 20 from both sides. What's 5 minus 20? Negative 15. Okay? And what option does that match with? So it's always nice. You guys remember the SAT when you did all the math and your answer was actually one of the choices? You guys remember what I'm talking about? Yeah. Okay, we got one more example. One more example. And then we'll be done. Thanks to our supply check, we're running a little close to the end of class. Hopefully that won't happen every time. The temperature in a crater on Mars is 0 degrees Celsius at 1 p.m. The temperature decreases 8 degrees Celsius every hour. At what time? That's what when means. When will the temperature be negative 50 degrees Celsius? Okay? So how much is it dropping every hour? Okay? So, all right. There is a thought process. And guys, this is something that we are just going to have to practice and get better at. All right? I'm going to explain as best I can. You have to figure out what operation do I need to do to solve this. And then the opposite of that operation goes in your equation. Okay? So if you know how many it's going per hour, okay, and you know how many it's dropping total, what could you do between those two numbers to figure out how long? You can divide. 50 divided by 8. That would tell you how long. So if you're dividing, okay, say, I have no idea how you got to divide. We're going to have to work through a lot of practice. If we're dividing to solve, what operation goes in our equation?
Multiplication.
Multiplication. It's that whole idea of opposite. You got to think backwards. Okay? So we're multiplying. It's negative 8 because it's dropping equals negative 50. There's my equation. And writing this equation is just as important as knowing the answer. So on a quiz or a test, if you get the answer without an equation, that's only half credit. Okay? So now that I have my equation, which is the hardest part, what do I do to solve?
Work it out.
Yep, work it out, which is what? Divide, which is what you said we needed to do. So come over here to the side and go 50 divided by 8. Don't worry about the negatives because we'll just write that sign in our answer. Okay, just divide the numbers. 50 divided by 8. All right, so we're going 6, 48, 2, put a decimal in because we're not done. 8 goes into 20 twice. 16, bring down our 0, and a 5. Okay, so this is the time, 6.25 hours. This is not our final answer. Okay? I need to figure out what time this means it's going to be. Remember, the starting time was 1 p.m. Okay? So at what time is it gonna be negative 50? At what time? Okay, so 6 hours later, it's what time? 7 p.m. But 0.25 is what part of a whole?
Order.
It's a quarter. So look at the clock. Okay. Oh, I heard it. What is 1/4 of an hour? We know half of an hour is 30 minutes.
15.
So what's 1/4? 15 minutes. So what time is it going to be? 7:15. You see how much was packed into that one problem? Okay. Now listen. It's the last thing that we did. So it's going to be kind of a pull together of a lot of different concepts. It's okay if that kind of went over your head. Just ask that you just keep practicing with me, and I'll keep trying to teach you and train you on how to solve these kinds of problems. I like calling them riddles. I don't like the word problem, because word problem is like, I hate word problems. I hate word problems, okay? But it just helps us to think critically. All right, so that's it for 1.1.